Hello everyone, this is the second video for quiz 6. I left off with finishing exercise number 6, so now let's continue with exercise number 7. Let g equals, so we have g is a function, and we're given this function in a set notation. That means that we're given all the ordered pairs that make up the function. Then we're given h, another function. H also is given in set notation. We want to find h composed with g. This is an open circle. This is a composition operation. Remember, the dot is multiplication. That's how we're going to differentiate between the two. So in here, we're asking to find the composition of h composed with g. Remember that when we have h composed with g, this equals h of g of x, which means g is inputted into h. In other words, if I'm starting from x, then g goes first to g of x, then h picks up g of x to h of g of x. So then the composition h composed with g is all the way from x to h of g of x. So what we're going to do now is we're going to start with g, and then we're going to end up at h of g of x. What I'm going to do is I'm going to write this as a mapping, because that will be easier to see. So I'm going to write g as a mapping. G takes -3 to 1. Takes 5 to -7. Takes 7 to -4. And takes -9 to 2. And then we have h. H takes 1 to -9 and -7 to -6. When we compose a function, we've got to have this as an assembly line. If I'm starting from an x and I get the image of it to g, then h is going to pick that up. So let's see what's happening here. Let's say we're starting from -3. -3 is mapping to 1. And then look at 1. H takes 1 and maps it to -9. So H composed with G is going to have the ordered pair -3, -9. Let's look at it again. How did I find that? -3 maps to -1 from G, and then H takes 1 and maps it to -9. And we're going to do this starting for all the inputs of G. So 5. 5 maps to -7, and H takes -7 to -6. So the other ordered pair is 5, -6. Let's look at seven. 7 is mapped to -4. But H does not have -4 in its domain. So H does not pick up -4 to map it to another number. So therefore, 7 is not mapped to anything from H composed with G. So we won't have any ordered pairs with 7. Let's look at -9. -9 maps to 2 from G, but 2 is not in the input of H. So H does not pick up 2 to give it an output. Therefore, -9 is not going to be in the domain of H composed with G. So with that being said, we found that H composed with G has only 2 ordered pairs. So what did we see from this example? The domain of the composition may not be all the domain of the function that we start with. And the ordered pairs are going to be only the ones that start from an input of G, and then if the output of that number is in the input of H, that's we're going to have the ordered pair that will be in H composed with G. Just follow each of the inputs of G to the output of H. Number 8, determine whether the following function is 1-to-1. Remember, 1-to-1 means only one output for each input, and also that output will be unique. So we're looking here at each of the ordered pairs. We're going to look at each ordered pair will have only one input, one output. So we're looking at 8-8, that's unique, 9-9, that's unique, 4-4, that's unique, 5-5, that's unique. So 8 is a 1-to-1 function. So the answer is yes. Number 9, let f of x be equal to -5x plus 2 and g of x, x squared plus 5. We want to find f plus g of x. Okay, so f plus g of x equals f of x plus g of x. That means that we're going to add these two functions together, and f of x is -5x plus 2, and g of x is x squared plus 5. Let's put this in parentheses. Then we're going to simplify. Since we don't have any number multiplying the first quantity, we're just get rid of the parentheses. -5x plus 2, and since we have a plus here, distribute that, plus x squared plus 5. This is a quadratic function, and write this in standard form. So x squared minus 5x, 2 plus 5 is 7, so plus 7. Number 10. Suppose the record times in the 2,000-meter race at a certain venue are a function of the number of rowers as shown in the figure. Okay, so we're given the graph there. The blue line is the graph. If R is the number of rowers and T is the time in minutes, then the formula T equals negative 0.35 R plus 8.67 models the relationship. Is this function invertible? Find the inverse. Few questions here. So one is the function invertible? Question 2 is find the inverse. And question 3, if the time for a 2,000-meter race was 7.11 minutes, then how many rowers were probably in the boat? All right, so before we start answering these 3 questions, so here's 1, 2, and 3. Let's see what we're dealing here. We have the equation T equals negative 0.39 times R plus 8.67. Let's write down what each of these variables represent. T is time in minutes. And R is the number of rowers. In the boat. If we look carefully here, this is a linear relationship, and we look at the graph as well. So the graph is a line. Linear relationship. Okay, so let's answer the first question. Is the function invertible? As we talked earlier in the previous example, an invertible function is a one-to-one function. And the lines are one-to-one function, therefore it's invertible. So lines are one-to-one functions. Therefore, they are invertible. One way to check whether a function is invertible or not, or one-to-one by having the graph, we look at the vertical test. The vertical test tells us that we have a function. So if we look in here, the vertical test passes. Every vertical line intersects with a graph only one time. And for the function to be one-to-one, we look at the horizontal line test, which means for every horizontal line, we intersect the graph only one time. So in this case, that is true as well. So by using the graph, the horizontal line test passes as well. 2, find the inverse. Okay, we did a problem like this before. To find the inverse, we want to write R as a function of T. So we're going to solve for R. Let's write this one more time here. T equals negative 0.39 times R plus 8.67. Okay, let's fix this R over here. Subtract 8.67 from both sides. Then we have t minus 8.67 equals negative 0.39 times r. Divide by negative 0.39 both sides. When you simplify this, you will get r equals t minus 8.67 over negative 0.39, which you can write as divide by negative numerator and denominator. And you can write this as 8.67 minus t over 0.39. Question 3. If the time for a 2,000-meter race was 7.11 minutes, then how many rowers were probably in the boat? Okay, so we are given t equals 7.11 minutes. We want to find r. Well, in second part of this exercise, we found r. So we know that r is 8.67 minus t divided by 0.39. Well, now we're going to plug in 7.11 for t. So r equals 8.67 minus 7.11 divided by 0.39, and do the arithmetic here, and then you get about 4 rowers in the boat. Eight 0.67 minus 7.11. I decided to do this step by step. 1.56 divided by 0.39. Number 11. Find f of g of x and g of f of x and determine whether the pair of functions f and g are inverses of each other. So here also we're given 2 questions to answer. One is find f composed with g and g composed with f. And 2, determine whether they are inverses. Okay, so let's do the first one first. F of g of x equals, so we're going to start with f. So we can write 2 over, instead of x, let's keep it blank, minus 9. Remember, x in a function is like a place value. We can put any value in it that is allowed for the domain. So instead of x, we're going to input g of x, because that's what f of g of x is. For x, we're going to put g of x. So what is g of x? 2 over x plus 9. 2 over x plus 9. This is g of x. And let's simplify this. Equals 2 over x plus 9 minus 9. 2 over 2 over x plus 9 minus 9 is 0. 2 times x over 2. We're dividing 2 by 2 over x, so we convert this into 2 times the reciprocal of the denominator. So this is x. And let's find g of f of x. G f of x. What this means is that we're going to start with g and then put f of x into it instead of x. So I'm going to do is I'm going to start with g. Oops, I don't need that long line. G is 2 over x, and I'm going to keep x open because there's a place value, plus 9. And instead of x and my open place value, I'm going to plug in f of x. And f of x is 2 over x minus 9. Let's simplify this. Two times, this is a fraction, and the denominator is a fraction, so we convert that into multiplication. So 2 times the reciprocal of the denominator, which is 2 over x minus 9. The reciprocal of it is x minus 9 over 2. Let's write this in red so we can see better. Oops, where is my red? There's my red. X minus 9 over 2. So the first fraction I convert into multiplication by the reciprocal of the denominator. Plus 9. 2 is like 2 over 1. Recognize that 2 will cancel out with 2. Then we have x minus 9 plus 9 equals x. All right, now we can answer the second question. The second question asks whether f and g are inverses. F and g are inverses. I'm going to write the theory here. F and g are inverses if the following is true. F composed with g of x, which is f of g of x is x, and g composed with f of x, which is g of f of x is x. If both these two compositions are x, then f and g are inverses. Now that we know that, what did we find in part 1? F of g of x is x, so that checks out. And g of f of x is x, that checks out as well. So the decision is f and g are inverses of each other. Number 13. Oh no, I'm not 13. I'm on number 12. Consider the graph of y equals third root of x minus 2. Is this function 1-to-1? All right, so since they're giving us the graph, we can use the graph, and I did the example previously. We know that this is a function, so the vertical line test is passed. We need to do the horizontal test. we need to do the horizontal line test to determine whether the function is 1 to 1. Remember, 1 to 1 is one input to a unique one output. Okay, so let's draw a vertical line. I take it back. Let's draw horizontal lines. We're doing the horizontal line test. We're going to see in how many points do these horizontal lines intersect with the graph. And you notice they're going to be intersecting only in one point. So what the horizontal line test actually does is it tells us that for every unique output, we're going to have only one input. So for a unique y, I find a unique x. So this function is 1 to 1. So the answer is yes. Number 13. We're given two functions in set notations of the ordered pairs for each of them, f and g. Find g over f. G divided by f. This actually is g of x divided by f of x. So one thing to remember is that when we do operations with these functions, in order for this operation to be done, we need to have g of x to be defined and f of x to be defined for a certain x that we have. So we're going to look at in here is, let's start with -3. -3, f is defined. Is g defined for -3? Yes. So g of -3 is 4. And f of -3 is 0. Okay. So let's say we're going to take x equals -3. G of -3 divided by f of -3. G of -3 is 4. How do I know that? In the g function, I have the ordered pair -3, 4, which means g of -3 is 4. I'm going to do the same thing on f. When x is -3, I have -3, 0 for f. That means that f of -3 is 0. 4 divided by 0 cannot be done. So g divided by f of -3 does not exist. Then we're going to take x equals 0. Let's take g of 0 divided by f of 0. You know where I'm heading. I'm going to check each of them. F of 0. G of 0 does not exist because there is no ordered pair that will have x to be 0. There is no 0 on the axis for G. So this does not exist. X equals 4. G of 4 divided by f of 4. G of 4, so let's look at G of 4. We have the ordered pair 4, 6 right here. So G of 4 is 6. F of 4 is 2. Because in f function, we have the ordered pair 4, 2. So 6 divided by 2 is 3. And we will see also that when x is 1, g of 1 is defined, but f of 1 is not defined. And for x equals 5, g of 5 is defined, f of 5 is not defined. So g divided by f is defined only for x equals 4. So we have only 1 point for g divided by f. Let's write this in set notation. G divided by f is only the point with coordinates 4, 3. What's the domain of it? Domain is 4. Make sure we write this in set notation. MATLAB already has the set notation. Already has given you this. All you got to do is put the numbers that belong to the domain, which in our case is 4. So what you can enter into those blank parentheses there is 4. That's how you're going to enter in MATLAB. Number 14. Find h of x and g of x such that f of x is h composed with g. Okay, so we have a square root function here. And inside square root, we have 2x minus 3. So what does this mean? This means that 2x plus 3 is inputted into the square root. Now we want f of x to be composition on this order, h composed with g of x, which is the same way as writing h of g of x, because g of x is inputted into h, then h is square root. Let's give the same colors here. H is the square root. And what remains for g of x? 2x plus 3. So the answer is h of x is square root of x, and g of x is 2x plus 3. Let's find this real quick so we check. I always like to check my answer. So let's say h composed with g of x, that is h of g of x. So I will start with h, which is the square root, and I have the blank in there instead of x. And into the blank, I'm gonna enter g of x, which is 2x plus 3. So this is the same as the one we started with. So that is f of x. Number 15. Use the horizontal line test to determine whether the function is 1-to-1. Oh, this is a good one. So for every horizontal line, we're going to look at how many points it intersects the graph. Well, the one I just drew, it intersects in only 1. That means that for that value of y, we have only 1 input. But if I draw y equals 2, this line intersects the graph in 3 points. What this means is that I will have 3 points for 3x values that will map to y equals 2. So here's the first one. Here's the second one. And here's the third one. So 3 different x's map to 2. So this means that this is not a 1-to-1 function. Because we have some y values that are outputs for 3 different x values. Number 16. For the function f of x equals x to the third minus 5, find two functions g of x and h of x such that f is h composed with g. Okay, so let's write this a little big. F of x equals x to the third minus 5. Well, I have a third power there, so one of the functions is going to be to the third. And then I have the quantity minus 5. So one of the function is going to be x minus 5, and the other function is going to be x to the third. Because we're inputting x to the third into x to the third is going to be our g. And x minus 5 is going to be our h. Let's find this real quick. H composed with g of x equals h of g of x, which equals, we start with h and we keep the place value. So instead of x, we're going to input g of x. What is g of x? X to the third. So we can simplify this into x to the third minus 5. And this is f of x. So we found them correctly. So again, the key here is to recognize the function that goes into the other function. X to the third is inputted into x minus 5. Number 17. Find f composed with g of x for the pair of functions and give the domain. As we've seen so far, when we compose functions, the order is important. So in this case, we have f composed with g of x what this means is that we have f of g of x. So g of x is inputted into f equals, so we start with f, and f is square root of 6 times x, 6 times, now keep the place value because I have only just x to put in there, and instead of x, I'm going to input g of x, and g of x is 1 over x. So this equals the square root of 6 over x. Domain was the domain of square root of 6 over x. Because we have square root, we need 6 over x to be positive, but we're dividing by x. So we actually need x to be greater than 0. So domain in interval notation is x is all x is greater than 0, so that is 0 to infinity, not including 0. Number 18. Let f of x is absolute value of x, g of x, x minus 4, hx, x to the third. We have h of x is x minus 4 to the third as a composition of these functions. So let's see if we're going to need all these functions. We may not need all the functions, but we're given 3 of them. We're going to see which ones will give us h. So let's see what we have here. We have a third power. Therefore, h will be needed. We have x minus 4. Therefore, g will be needed. So it seems like all we need is h and g. Let's see in which order we need them. So h of x equals x minus 4 to the third. So if I keep the place value for h, we have inputted into it x minus 4, which is g. So I'm trying to say is that g of x is inputted into h. So this is h of g of x, which is h composed with g. Okay, this is the last one for this quiz.